Hey guys, so this is the part that I kind of left off. This is the second part. So in the last, we did finding the distance from any point to a given line. So the point of us making or using a perpendicular line is so that it's like the shortest distance. So if we don't want to go from here to there because it would take longer, and we don't want to go from here to there because that would also take longer. The shortest way to get somewhere is through a straight line, and you know it's straight because it creates a perpendicular angle. And so, using what we looked at earlier, we know that the perpendicular angle, requires two lines to have slopes that multiply to -1. And if you're not sure what I'm talking about, then it's literally this. One slope of a line times the other slope, or the slope of another line, is equal to -1 if they are perpendicular. So here's what that looks like. Find the distance between the parallel lines. Well, first we want to make a perpendicular line, and we're like, okay, well, this is like I did that on purpose for it to obviously be wrong. That's not the shortest way for us to get there. So what is? Well, we could have, it will look like this. We're like, oh, well, how do we know if it's perpendicular, right? And again, we know it's perpendicular if the lines have a slope that multiply to -1. Hang on a second. Okay, so we're got to figure out like what's a good perpendicular line, right? So first, the slope. Well, these are parallel, so they have the same slope. So we could say, okay, well, the first m is -1. So first slope times the slope of this line that's supposed to be perpendicular, is going to be -1. Again, that's just from the from this, or not this. Here, the slopes of perpendicular lines. So they have to multiply together to make -1. So I'm going to go ahead and divide both sides by. So -1 I got from here. Like there's the slope. It's the number in front of x, and there's an invisible 1. So negative and a negative sign, so it's -1. So I'm going to divide both sides by -1. -1 divided by -1 is just 1. So now I know the perpendicular line has a slope of 1. What does that mean? It means to start from here, or literally anywhere, and I just continue going up 1 over 1. So for this, what that will look like, up 1 over 1, up 1 over 1, up 1 over 1, it will look like this. Or I can start from here, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And so let me erase to have a little bit more space to work. So I can keep going until I find like a nice and neat like space for me to be like, oh, this is where it obviously intersects, or whatever. Or I can start off by saying, okay, I know the slope is 1, so y equals mx plus b, but the m is 1. So 1x plus b. Sorry, to go back to it, we know the slope is going to be 1. I have to figure out y-intercept. We can use any of these lines, and since this one, I mean, you could go right here, we could say, oh, y equals x plus -1, which is x minus 1. That would be this line. Or I could go here and say, okay, well, the y-intercept is, it crosses through 0, so it's just y equals x. Again, it's up to you. There are many options, and it does just depend on where you start and where you identify the y-intercept to be. So, knowing that, I'm just going to use y equals x because that's pretty simple. Sorry, a lot of pausing this video. Okay, so going back to where we are, this point is clearly -2, -2. Or if not, or like in later problems where you don't have a graph, you could just plug in and find any point on the line. So you plug in -2 and you get out -2. And you want to know the distance from here to there, but we don't know what the coordinates are. So what we have to do is, one line is y equals x, and the other line is y equals -x plus 3. And if they intersect, I want to know where they are the same. And if they're the same, that means they're equal. So I could say x equals -x plus 3. And so I took this equation and I set it equal to that equation, y equals x, and then y equals -x plus 3. I said x equals -x plus 3, so that is where the lines will connect. So I add x to both sides. X plus x is 2x. 2x equals 3. I'll divide both sides by 2. I get x equals 3 over 2, or 1.5. To get y, then I'll go in here and I'll plug in 1.5. Y equals -1.5 plus 3. Using a calculator or just your noodle, -1.5 plus 3. Sorry. What the heck? -1.5 plus 3 is positive 1.5. So the -1.5, again, is just from, I plug in 1.5 because that's what I got when I set them equal to each other. That's the point of intersection. To get y, I plug in x. So to get an output, I put in an input. So the other point, and let me erase anything that might be confusing to you. We are using this, sorry if you can hear the background noise, that's my parents fawning over my niece, my baby niece. Anyways, so we have the point 1.5, 1.5, 1.5, 1.5. The last thing to do is find the distance between, so I'm going to use these two points to find the distance formula. Or sorry, I'm going to use these 2 points and use the distance formula to find the distance. So I have -2, -2, 1.5, 1.5. But yeah, then you would go just use the distance formula. Again, I covered in the last video, but as a reminder, man, this is being so annoying. x2 minus x1 squared plus y2, oops, it's so wonky, y2 minus y1 squared. So the x's you subtract and square, and then the y's you subtract and square, add them together, take a square root. So -2 goes here, minus 1.5, and so on and so forth. But I didn't want to focus on that. I just want to focus on finding the points in the first place because that's the hard part. So let me clear this, and let's do it again for one of these. Okie doke. So let's look at some ones without pictures. So you definitely don't have to draw this. I'm just showing you in case that's your preference. So you have 4x minus 6. That means up 4 over 4, up 4 over, or sorry, up 4 over 1, up 4 over 1, and then it starts off at -6. So let's say this is -6, and this is -10. Then it would look something like this. Let's say like that. Now let's say, again, obviously if you sketch it out and you are a little bit more neat, then you'll get a better, a more accurate picture, but that's the gist of what's happening is like, oh, start off at -6, go up 4 over 1, start off at -10, do the same thing. So you know the line's going to look like this. We don't know which 2 points. It could be here and here, could be there and there, and it literally just depends entirely on you and where you want it to be. So let's start off with this. I know the slope is going to be using the same procedure as for all these. I'm going to, the 2 slopes multiplied together equals -1. Well, now I just know that the slope is going to be -1/4. So I have y equals negative 1/4 x plus b. So you can pick like since it's so open-ended, like, oh, it could be this one, or oh, it could be that, like you could pick whatever sorry, you can pick whatever you want, and just to make it simple, sorry, I'm going to plug in 0 and find the y-intercept for this. So it is y equals negative 1/4 times 0 plus b. Oops. What am I doing? This doesn't even make any sense. So the thing with that is, let me undo that. It could go like this. It could go like this. And so you actually get to choose. So the B is open-ended. Sorry, I plugged it in like I was going to solve for something, but you don't have to do that. The B is open-ended. So just for kicks then, let's just say I wanted to start off at... let's just say I wanted to start off at 4. So it would be like starting off at 4... say y equals negative 1/4 x plus 4. So the reason I chose 4 is because I know that if I plug in 0 here, then I'll have a point at 0, 4. And that, since I'm going down 1/4, then it creates this like kind of neat, nice and neat, like down 1/4. Okay, well, down 1 would be 3. And then over 4 would be 4. Down 1 would make it 2. Over 4 would make it 8. So I have this nice and neat line. Of course, you could have picked any other point. It just would have also been fine. So if you picked 5, then you would go down 1/4. So from 5, it would go down to 4, and then over 4 would be 4. So this is just my line that I chose to make. You could literally choose anything you want for B. But let's see. Since I want it to connect, I want to see where they intersect with each line. And let me erase anything that could be confusing. So I'm using this line, and I'm trying to find this point and this point. Well, this one is y equals 4x minus 10. And this one is y equals 4x minus 6. So to get my 2 points, here's what I'm going to have to do. I'd say this line, y equals negative 1/4 times x plus 4. And then I have my other lines. That's the first one line, y equals 4x minus 6, and y equals 4x minus 10. I want to know where these connect with this one. So the way I'm going to do it is I will say y equals, I want to know where they're in the same spot, so I could say negative 1/4 x, sucks, negative 1/4 x plus 4 is equal to 4x minus 6 to find out where they intersect. And then separately, and after that, I will say negative 1/4 x plus 4 equals 4x minus 10, the other line. So here's what that's going to look like. To get rid of negative 1/4 x, I will go ahead and add 1/4 to both sides, 1/4 x to both sides. So plus 0.25, that's 0.25 is the same thing as a quarter, plus 0.25. Erase fix this. So I have 4, these nothing left there, equals 4.25x minus 6. And then I'll add 6 to both sides, and then I'll divide by 4.25. So I'll say 4 plus 6 is 10. 10 divided by 4.25 is, 2.35. Let's just say 2.35 to make it simple. So x is about 2.35. To get the y value, I'm going to take this 2.35 and plug it in. So y equals, and you could use the left side of the equation or the right side, it doesn't matter, for 2.35 minus 6. So again, just your calculator, 4 times 2.35 minus 6 is about 3.4. So now I know my point. Well, y is approximately equal to 3.4. So I know my first point is 2.35, 3.4. That is right here. I'm going to do that same process with this. Do that same process with this line and this one. So the equation that I'll set up is negative 1/4 x plus 4 equals 4x minus 10. And then you solve for x, and you plug it back in here to solve for y, or you could plug x back in there to get y. And then you will get another point. And so, actually, I shouldn't. I'm going to do this all the way through because, well, just give you guys one good thorough example. So I'm going to do the same thing, 0.25x, 0.25x, add 10. So 4 equals 4.25x minus 10 plus 10 plus 10, so that'll be 14 equals 4.25x. And to get x by itself, you divide both sides by 4.25. So I'll say 14 divided by 4.25. What the heck? And I get 3.29. So you could say 3.29. X is approximately equal to 3.29. To find y, you can plug it back in here, or you can plug it back in here. Or sorry, not here. Here or here, because those are the equations I used. So say 4, I'll just do this one. 4 times 3.29 minus 10. 3.16. So I have y is approximately equal to 3.16. And here's the last part. Now that I have my 2 points, 2.35 and 3.4, I have 3.29, 3.16. Then I will use the distance formula for these 2 points. That will be the end of it. So x2 minus x1 squared plus y2 minus y1 squared, and after you add them together, take the square root. That'll be the answer. But I know this was the hard part in terms of setting up all the equations and finding the perpendicular slope and blah, 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 blah. So if you're confused, rewatch it, go back bit by bit, or just ask me questions.